Good afternoon. So before doing that, I should write certain formulae. Then we should proceed for problems. Okay? And what those formulas are? Formula number 1. If is equals to Q1 cube 2 by 4 pi epsilon naught r square. This is called Coulomb's law. And you know 1 by 4 pi epsilon naught equals to 9 into 10 to the power 9 Newton meter square Coulomb to the power minus 2. And what is the dimension? Newton meter square Coulomb to the power minus 2 means m l t to the power minus 2 l to the power 2 I into t to the power minus 2. What is the dimension? The dimension is nothing but m l q t to the power minus 4 I to the power minus 2. This is your dimension of this. This is Coulomb's law. 2 point charges are at a distance r apart. This is Q1 and this is Q2. It is in free space. Permitting epsilon naught is called the permittivity in free space. And the second formula is that like this: F equals to Q into E. You know E is nothing but equals to F by Q. That is nothing but equals to Newton Coulomb to the power minus 1. This is electrical field intensity. And what is the dimension? Meter m l t to the power minus 2 I t to the power minus 1. Okay? And what is the dimension? M l t to the power minus 3 I to the power minus 1. This is the dimension of E, that is electrical field intensity. Am I clear? And the next is that 3, that is equals to V. V is equals to what? V equals to E into D. You may write like this: V equals to E into D. V equals to E into D, electrical field intensity into distance. And also E is equals to minus dV dr. This is also important relation. So you should know all these relations, these 3 relations. And relation number 4. From Gauss's theorem, we may write like this: E dot ds equals to Q by epsilon naught. E dot ds means n ds is nothing but Q by epsilon naught. Suppose this is area and this is perpendicular. So this is the direction of area, perpendicular to the area. Okay, so this is actually what? This is S. So you may write ds is a vector quantity equals to n into ds. What is n? N is a unit vector. If you take the mod value of n, if you take the mod value of n, if you take the mod value of n, you will get 1 because it is unit vector. If you take its mod value, it will be 1. Am I clear? So this is your Gauss's theorem. This is called GAUSS as Gauss's theorem. In case of electricity. In case of electricity, the Gauss's theorem. Okay, clear? Then if you wish to take a photograph, you just do it. Okay? Then this is all about your basic formulae. Next, I will write another formulae on the basis of which we can calculate all the problems. These are very basic formulae. Problem 1, 2, 3, and 4. And this is also, this is also 5. This is 5. This is 4. 1, 2, 3, 4, 5. This is formula. This is dimension. Okay, dimension of 1 by 4 by epsilon 0 and its value. So you remember these formulae. These are the basic formulae. Basic formulae in electrostatics. Basic formula in electrostatics. Am I clear? Epsilon naught you can calculate easily. 1 by 4 by epsilon 0 equals to this. 1 by 4 by epsilon 0 not equals to 9 into 10 to the power 9. Okay. So what is the value? Epsilon 0 equals to 1 by 4 pi 9 into 10 to the power 9. You calculate this, you will find the value. Okay. If you calculate this, you can find the value. Very easy. It will go 10 to the power minus 9. It will go on the upward direction. So what will be the value? Here 436 into 3.14. Okay, into 10 to the power minus 9. Very easy. And if you divide it 36 into this and divide it, then you will find 8 point something. Okay, then this is the value. You can calculate it. Now I will wipe out this portion. Should I wipe out this? Now I will write few formulae on what? On capacitance. On capacitance. I have already taught you capacitance, na? Have I taught you capacitance? Then basic formula for capacitance. Parallel plate capacitor. What capacitor? Formula number 1. Capacitors. This is another chapter. Capacitors. Okay. Formula number 1. Q equals to C into V. Q equals to C into V. Number 2. Parallel plate capacitors. C is equals to epsilon naught K A by D, or simply epsilon naught A by D, like this. Okay, and this is D, and this is D. So you can write like this. This is D, and in between them, if it is filled with space or air, then it will be like this. So this is a formula for a parallel plate capacitor, and this is a formula for spherical capacitor. Spherical capacitor, radius is r, and C is nothing but equals to 4 pi epsilon naught r. This is the capacitance for a spherical plate capacitor. Spherical plate capacitor. Am I clear or not? So these are the basic formulae. And what is the energy? Energy of a capacitor. Energy of a capacitor is nothing but, this is 4. Energy of a capacitor is nothing but E of a capacitor equal to half CV square, or half Q into V, or half Q square by C. This is energy of a capacitor. This is energy of a capacitor. How I can calculate it? How energy of a capacitor may be calculated? Suppose dW is the work done to take Q amount of charge through a potential difference. Through a potential difference, what? The potential difference PD hoche, PD equals to dV. Then Q into dV. Q into dV. And if you take integration, then it will be W. W means what? What means energy. Energy means Q equals to C into V dV. Lower limit 0, upper limit V. What will be the result? V square by 2. Upper limit V, lower limit 0. So what is the result? Half CV square. Here from half CV square, Q equals to C into V. So this is Q into V. And you know V equals to Q square by C square. So you place Q square by C square. So C will cancel out. This will be the result. So this is energy of a capacitor. Energy of a capacitor. These three formulas are very important. These four formulae. Another is common potential. Okay. Today what about this portion? Another is common potential. Another is common potential. What is the common potential? You'll see how it is calculated. How we calculate common potential? It's very easy. If you know the basic formulae, then you can calculate by yourself. Okay, is it easy or tough? Easy. So you see what I want to say. This is parallel plate capacitors, and now what I will teach you? Common potential. Suppose here is a capacitor. It is kept on a insulated substance. The capacitance is C1, and this is another capacitance, that is C2. It is placed here. If its radius is R1 and its radius is R2, then this is actually spherical capacitor, na? Now what is the charge? Its potential is V1. Its potential is V2. You consider V1 is greater than V2. Its initial charge is Q1. Its initial charge is Q2. Now you connect the two with a wire. Which wire? Conducting wire. Which wire? Conducting wire. Okay, what do you get? V1 to V2. Higher potential to lower potential. After a certain time, both the capacitors will be assume the same potential. So no charge will flow. So when V1 is larger, then the final charge will be Q1 dash, and here final charge will be Q2 dash. Here certain amount of charge it will lose. What will happen? Q1 dash equals to Q1 minus dq, and Q2 dash equals to Q2 plus dq. So this is final charge. The amount of charge that it will lose, the amount of charge that it will gain. So from conservation of charge principle, what can I write? Q1 plus Q2 equals to what? Q1 dash plus Q2 dash. Q1 means C1 V1, Q2 means C2 V2, Q1 dash means C1 into V, Q2 dash means C2 into V. What is the common potential? V is nothing but equals to C1 V1 plus C2 V2 divided by C1 plus C2. Am I clear or not? The common potential is this. What is the loss of energy in capacitor? Loss of energy is nothing but delta energy loss equals to a half C1 C2 by C1 plus C2 into V1 minus V2 whole square. This is energy loss. Loss of energy in a capacitor. Loss of energy. Loss of energy. How it manifests its energy loss? In the form of sound and light. In the form of loss, sound and light. In the form of sound and light, loss of energy is perceived. So it is greater than 0. That means positive. Loss is positive. So if you connect the two capacitors, the certain amount of energy will be lost. The loss is nothing but equal to half C1 C2 by C1 plus C2 into V1 minus V2 whole square. I have already proved this. So I have just only written this formula. So on the basis of these few formulae, you can solve almost all the problems. Okay? If you want to take a photograph of this, you can take a photograph, then I will go for problem. Okay? You take a photograph and then I will go for problems, solving process. It's a very easy way to solve the problem. And another is that what is potential, what is flux? Flux is nothing but equals to E into EA. Flux is nothing but, this is also flux. Electric flux equals to pi equals to flux electric E into A. This is another formula. So I have written a number of formulae. On the basis of that you can go ahead. What is quantization of charge? Quantization of charge is Q equals to plus minus NE. This is quantization of charge. Quantization of charge. You have to know that no charge can be less than E. E is the charge of an electron. The value of E is what? The value of E equals to minus 1.602 into 10 to the power minus 19 coulomb. So no charge is less than this. E cannot be fraction. Take a note. E cannot be fraction. E cannot be fraction. E generally cannot be fraction. So E is multiplied. N is multiplied. 1E, 2E, 3E, 4E, and this is called quantization of charges. Okay, take a photograph and then I will proceed for the next problem. Am I clear? Do you follow me properly? Now you see, I am wiping out this portion. Now wipe out this entire portion. Very easy. Priti, do you follow me? Yes. I am contented. As you are able to follow, then it is purpose will be served. As you all are very talented. Just to see this problem. Okay? Is it visible to you? Is it visible, na? 4 electric charges are there. 4 electric charges are there. Where it is? 4 electric charges. Q minus Q this. And what they are told are corners of a square of side L. 12. This is 12. And this is L and this is L. So total length is what? 12. Very easy. You see the electric potential at A. Electric potential at A means very easy. Distance by, potential at A means due to this, due to this, due to this, due to this, due to this and due to this, due to this, due to this, due to this and due to this. These are only the 4. As this is connected, so similarly this will also be connected in this way. What is the length? A. Suppose this one is A, this one is B, this one is C and this one is D. What is? It is here. It is A, na? It is A, na? Then you write A1, B1, C1, D1. Okay, no problem. What is AB1? AB1 is equals to how much? D square and D square. Okay. So what will be the result? Root over 2i's LH square plus L square. This is which theory I have applied? Pythagoras theory. Very good one. Okay. Then what you can write? You are eligible to write 2 to the 4 L square plus L square is equals to nothing but root over 5 L square, 2 L square, 4 L square plus L square. This is 5 L square. This is AB. Okay. So you can calculate it. What is the potential at A? Potential at A, VA equals to the potential due to D1, potential due to C1, potential due to VB1, potential due to VA1. For this potential, you have to calculate this potential for this and this. 4 potential. There are 4 points. What is the potential? What is VD1? VD1 means Q by positive Q, na? 4 pi epsilon naught into L. Am I clear? Q by L formula. Q by 4 pi epsilon 0 into L. Q by R, this is the formula. Q by 4 pi epsilon 0 into L. What it is? Q by 4 pi epsilon 0 into L. What is VC1? VC1 is minus. What can I write? I am able to write Q by 4 pi epsilon naught. What is the length? Same as this. AB1 equals to AC1. Root over this. What is the length? Root over 5 L square. Okay. What is the potential at V1? V1 is this. Then again it is same. Q by 4 pi epsilon naught root under 5 L square. What is the potential due to A1? Now L1 is nothing but equals to same as this. Q by 4 pi epsilon naught L. Now you take common. Which you can take common? This is twice, na? These two are identical, na? So you can write twice q by 4 pi epsilon naught L minus these two are identical. So you can write twice q divided by 4 pi epsilon naught L root 5. Am I clear? So what you can take? You can take common as 1 by 4 pi epsilon naught into 2 cube. Okay, 2 cube by L. What is the result? 1 minus 1 by root over 5. Just to see which resembles option number B. I mean, is it tough at all? Very easy or not? So you see, this is actually question asked in AIPMP 2011. That is a previous version of old version of NEET. Okay. So you just take a photograph of this and you will send this to group. Okay. So this is your solution. Am I clear? Now take a note as early as possible. Do it as early as possible. Okay. Now I will solve the next problem. Clear? So answer will be, this is your answer. Okay? Okay, completed? Now, just you see this one. How I solve this problem? Is it a top at all? The problem, the way I have solved the problem, is it very difficult problem? Do you think so, dear students? Do you think so? This is a typical problem? No, not at all. Okay. Then what should be this problem? How you can crack this problem? Two positive ions, each carrying charge q, are separated by a distance d. If F is the force of repulsion between the ions, the number of electrons missing from each ion will be. What it is? 2 point charges. 2 point charges. 2 point charges same are separated by a distance. Charge q separated by a distance. What? Separated by a distance d. Then what is the value? A equals to q square by 4 pi epsilon naught d square. What you have to find? N. You have to find n. The q square means loss of charge, means any total number of charge, the total charge that may be lost. That is n into a square by 4 pi epsilon 0 d square. So what should be the result? F into 4 pi epsilon naught d square by e square. Okay, 4 pi epsilon naught d square into f. 4 pi epsilon naught d square into f. And this is what? What problem?
Sir, this is n square.
That is will be equal to n square. This will be your answer. If n is like this, n will be equal to root over what? Root over 4 pi epsilon naught d square into f by e square. So this is your answer. Answer number C. Is it tough? So take a photograph. Now I will go for the next problem. I will go for the next problem to solve. Once it is done, you tell me. Easy na? Next problem. You see here. Here is the problem. You see. What you are hearing? The square of sides is L. All the sides are having what? L. All the sides E. E is acting along this direction. So perpendicular this is a perpendicular direction. So all are acting in which direction? E. E dot ds. E dot ds. E dot ds means E ds cos of theta means E ds the phi plus and cos of pi by 2 90 degree, then it is 0. So what should be the answer? 0, because they are acting in this direction. Perpendicular to this is perpendicular direction. Either this or in this way. Clear? So what is the next problem? Am I clear? Take a photograph. Then the next problem I will solve here is the next one is a series of combination of N1 capacitors. Okay, now next problem I will solve. I will help you to solve. You tell me how can I solve this problem? How can I solve this problem? You tell me. How can I solve this problem? Clear? You follow this problem? Then what is the next problem? How can I solve? You just see. A series of combination of N capacitors. Each capacitance C1. Series of combination of each capacitance C1. How many capacitors are there? Series combination of N1 capacitors. Series combination of N1 capacitors. Each capacitance C1 is charged by a force of potential difference 4 volt. So N capacitance, N1 number of capacitance, they are connected in this way. So what should be the resultant? 1 by C equals to how much? N1 by C1, isn't it? If it is 2 capacitors, then it will 2, 3 capacitors, C, then the series combination, so inverse. So what will be the result? C resultant, then what you can write? C is nothing but N1 by C is nothing but what? C is nothing but C resultant series is nothing but C1 by N1. When another parallel combinations of N2 capacitors, each of value what? C, C2, then N2. They are in what combination? Parallel. What should be that? C parallel will be equals to what? Will be equals to N2 into C2. C parallel means addition. Then what you have to write? Is charged by a source V. It has the same total energy stored in it as the first combination, the value of CT in terms of C1. So Here you have to calculate energy of the capacitor. Okay, very easy. What is the energy of this capacitors? Energy of these capacitors. Here potential is 4 volt. What is energy? Energy of the capacitor is equal to E S. Energy of the capacitor in series combination. Then what will be the value? Half CS into V square means 4 square. V square means 4 square. Clear? So this is initial. So what you can write? You are eligible to write like this: C1 by N1 into 16. C1 by N1 into 16. Am I clear? Here, what they have told you, the potential difference is V, same energy stored. Then E parallel equals to half Cp into V square. Same energy stored. V is a volt. What you have to find? Same. Is charged by a source of potential difference V. Of potential difference V. Here it is 4V. 4V means 4V square. Here it is 16V square. And here it is only V. Only V. And these two potentials these two energies are identical. So what can I write? I may write N2 C2 N2 V square. Okay, so ES equals to EP. Okay, ES equals to EP. ES equals to, they have told there the value of capacitor C2. What can I write? Therefore, I may write half C1 by N1 16 V square equals to parallel combination a half N2 C2 into V square. So you cancel the 2. Half will be cancelled out. What you have to find? You have to find what? C2. You have to find C2. You have to find C2. Then what will be the C2, value of C2? Very easy. C2 equals to how much? How much? C2 will be 16 C1 by N1 divided by N2. 16 N1 and with it 16 C1. You see here 16 C1 N1 N2. This one will be your answer. So is it tough? Very easy. Take a photograph so that you can solve the problem in future. Take a photograph of this problem. 25 number problem. It is very easy. In which year it was asked? 2010. So far I have solved some problems. The next problem. It is also very easy. Tell me. Take a photograph. Okay. This is also very easy. I will do it. Okay. And this answer will be like 0. What is the next problem? Or tell me. Should I solve the next one? Now let me wipe out this portion and you see the next portion is this. Problem number which one? Which one? Problem number? This one, na? This one I have solved. This one. The electric potential at a point Vxyz. What is electric potential is given by V equals to minus x square y minus x z cube plus 4. What you have to calculate? E. What you have to calculate? E. So what is E? E is nothing but grad V. You have to write this is a grad V is equals to I del V del x plus J del V del y plus K del V del Z. This is the meaning of this. This is called grad V. Grad V. Grad V means this. I have already taken the numerical value. So this will be your result. What is I dx? You see here. I into dv dx. Okay. dv dx means this one. dv dx means what? dv dx means minus twice x y. dv dx means minus twice x y minus z cube. Okay? Am I clear? Then what is dv dy plus what is dv dy? dv dy. dv dy means minus x square. dv dy means minus x square. These are constant. This is also constant 0. Plus dv dz. dv dz. That is, this is j. And this is k. What is dv dz? Only this portion will remain. Only here it will be minus z cube. Okay? Do you follow me or not? I suppose you have followed me. And initial, there is a negative sign. There is a negative sign. So if you take common, what you will write? You will write twice xy plus z cube into I plus j into x square plus k into z cube. Okay, this is your E. Which one resembles twice x cube plus j? X square y thrice x z thrice xz square x square y and last one xz square. Last one dv dz xz cube. Yes. Thrice z square. Okay. Thrice z square into thrice z square into x. Thrice z square into x. Thrice z square into x. This one. Okay. And it will be thrice z square into x. Okay, clear? Only I have done calculus, nothing else. So you take a note of this and you do the problem accordingly, and I suppose you will be able to solve the problem minus. And this is your result. So which one? And this one is right option. Okay. Then what is the next problem? How can I solve the problem? Next one. So have you taken the photograph? Take it as early as possible. Then I will solve the next one. 3 capacitors. The next one. Do it as early as possible. as early as I'm wiping out this portion, na? The next one. Which one is next? Which one? This one, last one. Last but not the least. Last but not the what? Last but not the least. Okay, is it clear? You see capacitance. You just read this problem. Problem number what? Problem number 27. Problem number 27. See capacitors. Each of capacitance C and breakdown voltage V are joined in series. The capacitance and breakdown voltage of the combination will be. Breakdown voltage means what? You know? Breakdown voltage means the voltage at which the capacitor is unable to hold charge. That means the maximum amount of charge that it can hold. So you can calculate this one. C capacitors, C capacitors, each C of breakdown voltage and breakdown voltage are joined in series. So it is easy. C capacitors are in series. C by 3. Isn't it? C by 3. The capacitor breakdown voltage of the combined will be, the breakdown voltage of the combined will be like this, C by 3, you are giving here, that is C by 3. And breakdown voltage, what will be the breakdown voltage? And breakdown voltage of each capacitor with the V hoy, তাহলে তিনটের জন্য Q equals to CV, so C equals to Q by V, 1 by V, okay? Clear? So what should be our answer? This is C by 3 and breakdown voltage will be 3 in series. 3 in series. So voltage will be divided V by 3. This will be your answer. Okay. The next one. We'll just take a photograph. And this problem you can solve on the next day. Tomorrow I will solve it. Okay, keep it. Take a photograph of this. You try at your home, and tomorrow I will solve it. Okay, no problem. This is a final. This is your home task. This is your home task. Okay, on the next day, that is tomorrow only, so 1, 2, 3, 4, 5, 6, 7, 8. Only 8 problems. 7, 8, 9, 10, 11, 12, 13. Only 8 problems have been given. Okay, so I'm closing here. I think you all have understood this problem. Tomorrow I will start from here. Okay, thank you.